Hello everyone, and welcome to another LearnEd quick tutorial video. In this video, we're going to learn how to convert this complex number 1 plus I into polar form. So right now, this complex number is written in rectangular form, which is in the form where we write the real component plus the imaginary component multiplied by I. So at the moment, our real component is equal to 1, and our imaginary component is also equal to 1 because it's 1 times I. So if we had to visualize this on an Argand diagram, we would have the real components on the x-axis and the imaginary components on the y-axis. And we have 1 in the real direction and 1 in the imaginary direction. So we actually have our coordinate around here. So that would be 1 plus I. So this is how we represent it in our rectangular form. Now what polar form is requiring for us to do is to represent the same coordinate, but this time we're going to talk about what distance it is from the origin, and we're going to use the letter r to represent that, so this distance here. And we're going to also refer to the angle it makes with the positive real axis. So that angle will be called theta. So the way we can do this is really just using a little bit of Pythagoras and trigonometry. So having a look at just the r first, so the distance that that coordinate has from the origin, we can kind of see that this forms a right angle. If we have a look at that, so we know that it's got a distance from here to here of 1 and a distance from here to here of 1. So when you have a right-angled triangle, we can apply Pythagoras' theorem. So there is a formula that you can learn. So r is equal to, so we're going to do the real component of our imaginary number, let's call it z. So the real component of the imaginary number squared plus the imaginary component of the complex number squared, and then all square rooted to give us the distance. This is all just derived from Pythagoras' theorem, a squared plus b squared is equal to c squared. So if we set c squared, we set c equal to r and we rearrange that, we're going to get that formula. So let's just substitute everything in and we're going to see what r is. So substituting in, we have 1 squared plus 1 squared all under the square root. That's going to just give us square root 2. So that's the distance we have from the origin. That's one part of our polar form. Now the other part of our polar form is theta. And there's also a formula that you can learn for this, but also you can figure it out using trigonometry. So looking back at our little triangle that we've got over here, we know that the opposite side to the angle is the imaginary component. So we're involving the opposite side and we're also involving the adjacent side if we write our little trigonometry letters. So which trigonometric ratio uses the opposite and the adjacent side? Well, that would be tan. And because we're finding theta, we're going to do tan inverse of, so the opposite over the adjacent, which in this scenario, and that's probably the one you'll want to remember, is tan inverse of the, so we start with the imaginary component on the top and the real component on the bottom. So that's a nice little formula you can remember. And then what we want to do is we just substitute those in that we already know. So it's just tan inverse of 1 over 1. And from our trig identities, we're basically asking what is tan inverse of 1? And we should know that that's 45 degrees, or we can also write that that's equal to pi over 4 in radians. So now that we've got our two components, we know what r is and we know what theta is, we can write our answer for z in polar form. So the form is written as r cis theta, which is a shorthand way of writing r bracket cos theta plus I sine theta. So this cis is a shorthand way of basically writing cos theta plus I sine theta, and that I is the complex number. Is the imaginary, is the complex number I. So now what we can do is we just substitute, we know what r is and we know what theta is. Well, just write it in the r cis theta because it's the shorthand way. So our answer would be square root of 2 cis, and then we'll just keep it in radians, so pi over 4, just squish that in there. There you go. So that's our final answer for what is the polar form of this complex number z. And if we wanted to double check that it's the correct answer, all you would have to do is expand this part here with those values substituted in and evaluate the cosine sign at that pi on 4, and after simplifying it will actually lead you back into this rectangular form here. So in another video we'll talk about how you can actually go in the opposite direction from the polar form and back into the rectangular form that we started with today. Alright, well done for following along, and we hope to see you in another video.